Hello, everybody. Wow, it's pretty much a full house. I'm excited. Oh, hi, everyone. Thank you so much for taking the time out of your busy schedule to join me today for our session on Compose Multiplatform. We have a fun little journey ahead of us, during which we'll see how Compose Multiplatform from JetBrains equips you as modern Android developers with a bunch of new superpowers that make it possible for you to build shared mobile user interfaces that run on Android as well as on iOS. There's a bunch of stuff I want to go through with you today. We'll see where Compose Multiplatform fits into the overall story of Kotlin Multiplatform. We'll see that by using established APIs, it's actually quite easy to adopt Compose Multiplatform, or at the very least much smoother than you might expect. And also you'll see how quickly you can transfer your skills to build some really cool stuff for iOS. I've brought with me a couple of live demos. I'll also attempt a speed run at migrating a small Android app to iOS. So yeah, there's a lot of stuff happening. We have about 40 minutes, so let's get into that. I don't want to be rude though, so hello, my name is Sebastian. And I think my slides are frozen. There we go. My name is Sebastian. I'm one of the developer advocates for Kotlin and for Compose Multiplatform at JetBrains. You may have seen me before on the Kotlin YouTube channel or heard my voice on the Talking Kotlin podcast together with Hadi. I'm also a huge Back to the Future fan. This is foreshadowing. This will become relevant later. Okay, so before we dive into the Compose Multiplatform story, I just want to do a super brief recap on the classic Kotlin multi-platform case, just so that we're all kind of at the same stage. We're looking at the mobile case here because that one's probably the most popular and hopefully also resonates with you. So here's the scenario. Let's say you're working on a product and you need to ship an Android app and an iOS app. And so rather than build two entirely separate applications with Kotlin Multiplatform, you can kind of eliminate the code duplication and share code between the different targets. And the idea here was always to share the code that's supposed to behave the same between multiple platforms, but not give up access to the platform-specific APIs and capabilities that you do want to use in your apps. So rather than choosing between a cross-platform framework or native apps, you kind of get cross-platform and native. Now, in this setup, you would write platform-specific native UIs and share whatever business logic wherever it makes sense, and then interface with the target platforms to deliver your apps. That approach has already been validated by tons of projects that are already successful using Kotlin Multiplatform in production and at scale, and that use case is also not going away. But what was kind of missing in this story was a solution for when you don't want to build and maintain native UIs for your platforms separately. That might be because you maybe don't have enough people, or maybe you don't have enough time, or maybe you have a new thing and you really just want to get it into the hands of as many people as fast as possible. And that's exactly what Compose Multiplatform enables. It allows you to implement your user interfaces once and then use it for all the platforms you target. Now, this is probably a good place to step back for a second and acknowledge that Compose Multiplatform actually has numerous targets. It can target Android, and that just works via Jetpack Compose from Google. It targets iOS, which we're going to focus on the most today, which is currently in alpha. But it also targets desktop, for example, which we already stabilized and which is running in production on over 1 million macOS, Linux, and Windows machines out there. If you've ever used JetBrains Toolbox, the tool that we use to manage all of our IDEs, that's a Compose application running on desktop. And there's also the web target that works via Kotlin for WebAssembly. This one is the latest target, and it's still currently experimental, but it was actually already featured at this year's Google I/O from the Chrome team as one of their case studies because they're very exciting. They're very excited about what the web target holds for the future of the web. So today we're going to zoom in on the case of building shared mobile UIs. So for modern Android developers like yourself, Compose Multiplatform actually comes with a very unique and I would say quite magical value proposition. Because Compose Multiplatform allows you to build shared user interfaces using the APIs that you probably have already seen and used. Because except for a few very minor differences, the APIs in Compose Multiplatform and Jetpack Compose, they're the same. So that means that any knowledge that you have or that you're currently building and learning, that stuff all translates directly to the multi-platform case as well. You can use your skills for building modern Android apps and apply them directly to building shared mobile apps as well. Okay, all sounds great on paper, but what does that actually look like in practice? So I've brought with me a small Compose Multiplatform app that we can take a look at that hopefully demonstrates a couple of the capabilities of the framework quite nicely. At least for me personally, when there's a cute cat involved, I always have an easier time kind of remembering subjects. So we're going to take a look at that. I'm going to quickly switch over to my iPhone, and I'm going to bring up this application. So we'll do that in a second here. Very good. Now, sure, this seems fine. Now, before I do this though, I just want to share a super brief anecdote. When I plugged in my phone, I realized something very crazy, and that's the time on an iPhone, when you switch it to mirroring mode, it switches to 9:41 a.m. And apparently this is a thing that Apple does for all their demos. So apparently this also just happens for when you regularly plug in your phone. I was very suspicious because I had to do a double take while I was up here on stage. I'm like, is it the right time? Anyway, okay. So let's take a look at our small little app here. We call it the Memories Viewer, and here you can see our favorite little mascot cat again. And this is an app built entirely in Compose Multiplatform. So as you can see, we have a nice grid of images down here where I can store all the most important events of my life. Like, for example, when I got a really, really cute donut. Or, when we actually went on stage at KotlinConf and we showed off Compose Multiplatform for the first time with my colleague Nikita. But yeah, of course, one of my core memories is also meeting the cat of my best friend for the first time. And if you actually read this text, you'll find that this kitty really loves soup. That's one of the things that she really does like. So if we scroll down here and we actually cannot, I wish this actually is a little bit smoother on my screen down here than up here, so you'll just have to take my word that this actually runs at 60 frames a second. We can actually take a look down here on the Apple map, and we can see that we actually placed her right in the center of Munich, my hometown, where a famous soup restaurant is also located. So we have her right here. Of course, it wouldn't be an image app if we didn't have some sort of pinch to zoom where we could take a closer look at this kitty or do things like apply a couple of filters, although the blur filter maybe isn't all that useful for your images. Yeah. Of course, since I store all my memories in this app, I would also love to invite you to join me in a picture. So I'm just going to open up our camera view here, and I'll do a little bit of a selfie. If you would not like to be in the selfie, you can use the conference-provided sensor bars that you all have hanging around your neck to maybe like block out your face, or maybe you can slouch behind a neighbor, something like that. Okay, so we'll try that for a second. I'll try to get us all in frame. This is a very wide room, so I apologize for the folks. I don't have that wide of a wide-angle lens. All right, wonderful. And if I wanted to, and if I wasn't currently on a mental health Twitter break, I could also take this and actually share this on any kind of social media that I would like. But you'll see that it actually places us quite nicely right here in the middle of New York. Wonderful. Okay, so that concludes our little demo. And we'll go back. Actually, before we go back though, to convince yourselves that this is actually a shared application, and I didn't just build this stuff in like Swift UI, for example, here's the same app also running on Android. It's the exact same application and it behaves the same way. So if we want to go in and, for example, look at Kenya's post, you'll see that this time we see a Google map where she's located. And we get the exact same functionality. We can still interface with the camera. I just can't do that because I'm on an emulator. Great, wonderful. Okay, so now we've actually seen an app that runs Compose Multiplatform on 2 mobile targets on iOS and on Android. I actually did write this demo together with a few colleagues on the Compose Multiplatform team. But I actually have to admit that I'm not like an iOS developer at all. Like I don't have a background in like Swift UI or anything like that. But with Compose Multiplatform, I also didn't have to because I could just reuse my knowledge from Jetpack Compose. We can actually break down this kind of overall setup of the application to take a bit of a closer look. So if you take a look at the image up here, for example, that's just an image composable. So it's the exact same one that's being used on Android. And I just want to be clear, this isn't like a re-implementation or like a mock or something. Like it's literally the Android X Compose Foundation implementation. If you look at this grid down here, that's also just a lazy vertical grid. So again, if you know the APIs of how you specify items in that, it works the exact same way over here. We did go a bit fancy with the little button that we have down here. Of course, we could have just used one of the built-in button composables, but we wanted to do a bunch of customizations. So we instead used a box with a couple of modifiers. And again, if you've done Jetpack Compose, none of this should be particularly surprising to you. It's just a size modifier, a clipping modifier, and a clickable modifier. They work exactly the way that you would expect. So this actually stretches to most UI topics. So animations actually use the same APIs and DSLs as on Android. If you look at like the little parallax effect while I was scrolling, that's also built on top of Compose APIs, as are transitions and so on. So really the main takeaway when it comes to building with Compose Multiplatform is that you're building on the exact same building blocks, the same abstractions that you've already used on Android, which makes it really, really quick to get started. Now, a fully featured app, of course, also integrates with what the operating system has to offer, and that also has to happen on the UI layer. We saw the camera feed in our case, and also the Apple Maps, for example, but there's of course others like web views that you might want to have in your applications. Now these are obviously target specific, but because we are building our app on top of Kotlin Multiplatform, we can actually still access everything the platform has to offer. So that means we can build something like a common location visualizer that then has different platform-specific implementations. And then Compose Multiplatform takes care of providing the necessary adapter functions. So for example, while it would be a Google map on Android, you could have an Apple map that actually uses MapKit, so the MK map view on iOS. And that works exactly as you would expect it to. We also kind of want to do the other way around. So rather than just bringing native views into Compose, we also want to be able to bring Compose into your Swift UI applications, specifically because we want to enable you to gradually adopt Compose Multiplatform. So far, we've seen an app that was entirely built in Compose, but if you already have an existing Swift UI application, you can actually have individual screens be rendered in Compose as well. That's what you see here in this screenshot. The navigation bar at the top and the tab bar at the bottom, those are actually built in Swift UI. And then the actual chat view with like the little chat bubbles and the images, that's a Compose view that's embedded inside Swift UI. And you can see that it meshes quite nicely. We can even have like floating Swift UI text fields on top of the Compose-based chat, and that all works and looks great. So you don't have to go all in right away. You can also bring Compose Multiplatform into just some parts of your apps and adopt it gradually. Now, with all these things that we've seen in the demo app, I think it's also probably time to do a little bit of expectation management. Let me just steal my cursor over here. Give me just 2 seconds. There we go. Otherwise, my clicking is going to be hard. Because I do want to stress that I said this kind of on the wayside beforehand. It is currently in alpha. There's still a lot of things that we're working on and that we are kind of making progress on, but I think it's important to know kind of where the technology is at. Because at the end of the day, we do want to make sure that when you build something with Compose Multiplatform, it feels great no matter the platform that you target. And this starts on the very little things, like, for example, gestures or also scroll physics. In fact, just a couple of weeks, we made a new release of Compose Multiplatform that provides you a new way of scrolling and overscroll that are practically indistinguishable from like Swift UI applications. This also extends further to navigation principles. So things like built-in lifecycle and resource management, as well as more complex interactions. Like, for example, text selection, context menus, dialogues, and pop-ups, all these kind of things. So we're already in the process of addressing a lot of these. So we're already providing new commonized APIs, and we also continue on making them just work and feel great. But as we'll see in a bit, the community is actually also very much stepping up on a couple of these topics. We also want to make sure that Compose Multiplatform applications, there we go, provide really solid accessibility integrations and respect user choices. And that includes everything from text to voice to zoom to contrast preferences that users might set. As one example that we've done quite recently, we've introduced support for dynamic text, which is one of the Apple APIs where users can adapt font sizes to what they can comfortably read. And that just works out of the box with Compose Multiplatform apps as well now. Obviously, this is a lot of points, but I just kind of want to get the point across that we actually want to put proper thought into all the facets that go into building cross-platform applications with Compose Multiplatform so that they always feel great. Now, one more topic that's, of course, very important is consistently providing absolutely smooth performance, even on high refresh rate displays. This is something where we're actually collaborating quite closely with the Kotlin native team, who are in charge of everything from building the actual compiler to the garbage collector that then runs on the native devices. If you are curious about where we are at with this and what goes into this in the future, I would suggest listening to my colleague Nikita, who's unfortunately slightly cut off down here. But yeah, he's our technical expert on one of those subjects. So if you take a look at the KotlinConf 23 talk on Compose Multiplatform on iOS, he'll share a little bit more details there. You can already find that one on the Kotlin YouTube channel. Just to kind of give you a little bit of context, because I realized that the projector here seems to be slightly choppy. On regular devices, we consistently already hit the 60 FPS benchmark, but if you're on higher refresh rate displays, so the Pro models that have 120 FPS, we sometimes find ourselves in the 110 FPS area. So obviously, we just kind of want to push it all the way to the native feeling. So even though there's still a lot of stuff that is work in progress with Compose Multiplatform, there is a lot of pieces that you can experiment with and that you can already use. And I'd like to take a look at a couple of projects that have already used Compose Multiplatform successfully, just to kind of give you maybe a little bit of inspiration. And probably there couldn't be a better fit than the first example that I've brought with me, which is the DroidCon New York City app. So the folks from TouchLab actually built the DroidCon app with a pre-alpha version of Compose Multiplatform in Android and already rolled that out. So yeah, as you'll see, even though we only announced this technology earlier this year, the New York City 22 app was also already on the App Store using this technology, essentially in production. So now you see how the time traveling part from beforehand might come in. So they actually also wrote a very nice article about the overall experience of building something with Compose Multiplatform, and keeping in mind that this was at a time where no one even knew the technology existed, and they just kind of plucked those out of our open source artifacts. They said the dev process went way better than anybody expected, which I would say in that stage is definitely a win. If you do want to check it out yourself and you happen to have an iPhone, you can download this app on the App Store and kind of give it a try or a go. I also want to talk about two other cases. The first one is Instabee, which is a logistics company that comes from the Nordics, but is now already present in 7 different countries and cooperates with over thousands of online merchants. And they reach about 45 million customers with their delivery services. So they're actually using Compose Multiplatform to deliver millions of parcels every month. That's right, they have Compose Multiplatform already running in production. So specifically what they do is they have a fleet of delivery drivers that have iOS and Android devices, and they equip them with the drivers app or the deliverer app that runs on Compose Multiplatform. They actually already started out their app being 100% Jetpack Compose from the start. And they also already anticipated that they wanted to do some kind of multi-platform. So they kind of architected their code in a way that it was mostly common code, so it wasn't platform specific, and already embraced the kind of Kotlin multi-platform architecture paradigms. And because of that, they saw their results, because even though it isn't a small app, they got their first prototype working on iOS within just a couple of days. And between the two platforms, the app looks and feels exactly the same. That's the power of this, using the APIs you already know, that we've already talked about. Of course, in classic time-traveling fashion, the first time I heard about this case was 5 minutes before we announced Compose Multiplatform publicly. They had already deployed it into production. Again, I'm not sure how it works, but I'm glad that it works for them. Yeah, one of the, and my last case that I want to talk about is VeloBank, which is a Polish banking provider who also did something quite similar. They used Compose Multiplatform to create a prototype for their iOS banking app, as well as a desktop app for their banking software, which is honestly great because it once again serves as a reminder that Compose Multiplatform is more than just mobile. And from their perspective and from their experience, they said they had the right abstractions in place, so it mostly just worked, which honestly I think is quite a delightful statement to make. So overall, going from Android to iOS with Compose Multiplatform can go really quickly, it seems like, if the circumstances are right and the right abstractions are in place. But I figured that rather than just telling you about this, we'll see how porting a tiny application from Android to iOS via Compose Multiplatform would look like. So what we're going to be doing is we're going to be porting the Rally example application. If you've gone through the Jetpack Compose Code Labs from Google, you might have actually seen this app before, because it's one of the official examples in the Jetpack Compose training materials. It's a small, like, little budgeting app, and I think it's pretty well suited for this case, because while it has a somewhat complex UI, with a bunch of custom components as well, like the pie charts. You'll also see a couple of animations when we look at the app and so on. It's not a huge application, so we're not dealing with a couple of thousand files, so I'm comfortable doing it here on stage. This is going to be a narrated speed run rather than a tutorial, so I can't go into all the details here. That's just due to time constraints. But I do want to do it kind of like from start to finish without skipping anything, so that you can actually see what kind of goes into it. Small note is that since we are doing iOS development here, a Mac is unfortunately required. That's an external limitation. Okay, so we are going to dive in. First of all, let me close our previous project, and we can take a look at the actual application running here, and I'll do you the favor of also zooming the text just a little bit. Yeah, so this is the actual application, just running on Android as the example kind of works. So you have a couple of different screens. You have an alert that's kind of like flashing up there. All of these kind of basic things. So the question is, of course, first of all, how do you get started with a new Compose project? Well, you go to jb.gg/compose, or you just type Compose Multiplatform into a search engine of your choice. Once you've done that, you'll land on our landing page, and from there you can actually find, for example, our templates that are specific for mobile devices. So in this case, this would be the mobile application, which shares between Android and iOS. We also have templates if you want to do desktop development, for example. I'm not going to be using this specific template today. Instead, I'm going to use a community maintained template from Moco, which are a bunch of additional libraries that make it slightly easier to do the migration to Kotlin multi-platform if you're already on Android. This is a community maintained library, and they kind of provide adapters and interfaces for all kinds of things, from permissions to resources to biometry. They also just have a template, which, as you'll see, is actually just a fork of our template with a couple of extra things added to it, and you'll see that even the screenshots look the same. This is as easy as just clicking use this template and then creating a new repository. Because I don't trust the conference Wi-Fi, I've already done that in advance, but I've not touched the project in any other way. So this is what happens once the project's actually imported. You get started in your IDE. So let me just make sure. I'll try to make the text a little bit bigger here. I hope this is slightly more comfortable for you. So my development setup is just a regular recent Android Studio. The only difference is that I have the Kotlin Multiplatform mobile plugin installed that allows me to run iOS run configurations as well. So let me switch from the Android view to the project view so that we can get an actual overview of the project. We do have an Android app, but we also have an Xcode project for iOS, because this is a template that provides us with a bunch of different implementations or a bunch of different samples. We can actually just get rid of these for the start. We'll delete all of these, and we'll hollow out our actual app. So this is kind of like the very basic setup that we might have. And in here, we can also get rid of our resources, because we don't really need those. Okay, so at this point, we should have essentially already be at the point where we can build a cross-platform application. So let me just make sure that I do this on the emulator so that you can actually see this. Of course, this application shouldn't do much. It should just show us a blank screen. And we'll see that indeed, on Android, we just have a blank screen. And then once the simulator starts up in a moment, we'll see that that is going to do the same. We'll just give that a moment to happen in the background. In the meantime, we can actually start with our real migration. And our migration starts deceptively simple. We're going to grab the whole project, copy, whole project, paste. Okay, done. Well, not exactly done. I do hope that my iOS runner is going to work in a second, but we'll do that in just a moment. We're also going to bring over the resources that we had in our original project. We have a couple of these here, so I'm just going to copy these and paste them into my resources directory, and we'll add them. So at this point, once we have these resources, we need to make a couple of small changes. That's just because the resources library that I'm using is from the third-party Moco. Those folks have a slightly different naming scheme, so instead of font, it's actually called fonts. And instead of values for our strings, this is called base. But those should be the only two changes. So now we generate the actual resources so that we have the symbols that can actually access the resources across the different platforms. Now I do hope that if I run my iOS application here again, it will be okay. My application has a small trouble And that makes sense, because if we go into our actual application now, we'll see that while certain files, like for example the actual data layer, which stays the same, of course doesn't need any changes, if we go into our UI, we'll see there's a bunch of unresolved symbols. That is because rather than using the built-in Android string resource, we need to use the resources that come from our multi-platform application. So to make sure that these are linked in the correct location, I'm just going to go into my configuration here and make sure that they actually come from the same package. So we'll set this to, this is example compose rally, and we'll do a quick synchronization. Thank you very much. You are my savior, most likely. Great. OK, so with this, we should actually be able to see that rather than importing .r, we should now have an MR symbol. I really hope we do. So we'll import this one, and we'll import this one. There we go. So you'll see that we have a, that did not update correctly. Give me 2 seconds, we'll just do a quick clean, a quick build again. Yeah, and now that should work. Great, so given the MR symbol, we can now access strings total. And this one comes from example compose rally MR rather than R. So what we can just do is we can open up our replace in files, and we'll take anywhere where this import is, and we'll replace it with our new import. So that's across 5 different files. I really wish my screen resolution was big enough that I could actually have the replace all button that's down here. I did not account for this. Give me 2 seconds. There it is. Very good. So we'll replace all of these, and we'll also make sure that we have the correct new lines in place. So this already removes a large part of our troubles. And we also know that rather than using string resource, this import, we use this different import. So we'll once again do just a replace on string resource and grab this one and put it in. And this is again across 4 different files. So we should be able to remove this part. Great. We can now go through and just kind of adjust our other files and see whether there's any more errors that are happening. Here we have another implementation of R rather than MR, and it's once again strings. We've already filed a ticket with the folks from Moco, and they're already in the process of changing those APIs so that you don't actually have to make these changes, and you'll just have to switch out the imports. But it is a community-led project, so obviously we can expect to give them a little bit of time here. One of the things that I find very nice is I can actually look at the animated circle, and I can see that I don't have to touch any of this. It just works the same way. In my common UI, if I scroll through, we have a couple of issues. First of all, we have an icon that seems to be missing. We obviously don't want to just remove the icon, so we can go into our build file, go into our common dependencies, and just add a dependency for the compose. Sorry, no, This is the first time I've ever seen my Mac just completely hang. Cool. Give me 2 seconds here, see if it comes back. Oh, it does come back the moment I unplug my screen. Look at that. Hmm? Cool. Don't you just love this? Thank you. Okay. So, interestingly enough, we didn't even have an iOS part running here, so that's just, I'm just going to blame Android Studio. Great. Okay. Delightful. So, going back here, hopefully, Compose. There we go. Material icons extended. That wasn't so hard. Okay, and we'll go back in, and we'll see that I think we were at the common UI, because we're just kind of working our way through from the top to the bottom. Okay, so one of the problems that we're seeing here is that there's a use of decimal format. We'll just remove the import for now. We'll make sure that we use the correct MR strings. Here we'll go down a little bit, and yeah, so this is actually a point where we notice that our Kotlin standard library could be slightly better in the case for decimal format. We don't have a built-in version for this multi-platform yet, so I just brought my own. If you do want to not have to have this snippet in your code base, you can of course either use a third-party library or you could vote for KT21644 utility functions for formatting decimal numbers to the Kotlin common library. Either works. Another point where we currently still have to make a little bit of a concession is that we don't have the alert dialog in this specific setup, but I can just stop this one out for purposes of the demo. The only thing I need to make sure is that the text is a composable function and that the buttons are also a composable function. Funnily enough, with the latest release of Compose Multiplatform, this already works. You don't have to make any changes, but I'm using a community template, so we're like slightly like a week behind or so. In the top bar, we're using a locale, but we can just defer this to the Kotlin standard libraries implementation for locales. In the statement body, it seems like everything's already working just fine. The overview body is using a preview annotation that you can still use as long as you're doing Android development. We just don't have common previews yet because we're trying to figure out the best way to implement those. We also have a locale here. So we'll remove the locale. We'll remove this preview annotation, but again, if you're just doing Android development and you're just working on the Android part of your application, this stuff all still works. Let's see if there's anything else. We do have another string resource that we need to adjust here. I could have probably also done this with a search and replace, but I'm sure this works just as well. Cool. In the theme, yeah, the colors are all the same. The rally theme is slightly different because previously we were using this kind of definition for font families. There's again just a slight difference in the APIs. I have a small snippet for that, but those behave exactly the same otherwise. The activity that's Android specific obviously doesn't actually need to be in our multi-platform code. We have a different entry point that's already provided by the template, so we'll just keep the Rally app around. We'll remove our component activities out here. The Rally screen already works exactly as expected, and now all we have to do in our app is actually call into Rally app. Now the demo gods have given and taken away, so we're gonna see but I believe that we have done everything that should make this application work on iOS. And in the meantime, of course, we can also still demonstrate that the same application also works on Android. Because when the build doesn't work, just start a second parallel one. And I'm sure that's going to make it much easier, because concurrent systems, as we all know, are much more reliable than simple systems. Okay, so we have our reference application already built again, and we're just waiting for another moment for the iOS simulator to pop up. I am filled with suspense. Look at that, and here's the application. So you can see there's a couple of things that aren't perfect yet. For example, you have this white bar at the bottom and at the top. We actually released just in Compose 1.5 the insets API so that you can absolutely have your application stretch the whole way and even around Apple's magic touch bar island thing, whatever they call it. Yeah, but everything else, if I switch over here, you'll see all the animations. Those run on my machine at a smooth 60 frames per second. Again, unfortunately, my monitor here isn't really doing that justice. But that all works. Our decimal formats are all nicely formatted as we expect them to. Yeah, so the application just works. Scrolling works as you might be used to. Sweet. So, we have seen that for the vast majority, like for all the actual complex stuff, the APIs are exactly the same. I don't understand how that custom circle animation is done. I don't have to. I just copied the code and it worked. The couple of like bumps that we saw in the road here, those are just because a couple of things aren't quite aligned yet. But I feel like for a pre-release thing that works together with a community thing, that's already pretty forgivable. There are libraries and templates available that make it rather easy to get started. We have the official ones as well as the community maintained ones. And we turned our iOS application we turned our Android application into an iOS application within minutes. That was, I find it very funny that this is best case scenario because from up here it did not feel like the best case scenario with the whole unplugging and replugging. But that was, of course, I think pretty smooth. It is important to remember, though, that Compose multi-platform apps are Kotlin multi-platform apps, which is great on the one hand, because you obviously get proper native binaries for all your targets, but it also means that there really isn't a magic switch you can just flip and expect your app to work on iOS. Even with a small example, we made a couple of changes and we saw that some functionality, like decimal format, wasn't available as a cross-platform implementation. Yeah. But the case studies that we saw from Instabe, Velobank, those had already kind of anticipated that they wanted to do multi-platform in advance and designed their apps accordingly. Yeah. So depending on what the app does, we'll probably have to put in some work adapting it and maybe switching out some parts of your application. So I just want to give you kind of like a brief overview of what the ecosystem of Kotlin multi-platform and Compose multi-platform has to offer for you so that you have like a starting point for yourself. Because we're all standing on the shoulders of giants, right? There's a couple of different topics that are probably important and that most apps need to work with. Some of those are more Compose related, some of them are just more multi-platform related, but I wanted to include all of them here. One of the very promising trends, and the place where I do want to say thank you, especially to Google though, is that we're seeing more and more official Google libraries come to Kotlin multi-platform. A couple of months ago, they already announced that collections, data store, and annotations are becoming Kotlin multi-platform libraries, which means you can use them in those projects. You don't have to switch them out. It works just as expected. And as more and more libraries do that, obviously, the easier and easier it even gets for you to do your migrations. It's also one of the fun parts why if you go to the Android API docs, you now find a drop-down sometimes that has the word iOS in it, which I never thought would be the case. I'm quite excited about that. It's pretty cool. All right. So we don't have first-party support for Compose navigation inside Compose multi-platform yet, but the community has stepped up. Two of the libraries are, one of them is Voyager, which provides kind of a screen-based navigation. There's also Pre-Compose, which tries to emulate the Android APIs as closely as possible. So if you're familiar with Jetpack Lifecycle view model navigation, this is a library that works really well for you and that you should get started with quite easily. For everything from resource management to platform integrations, we've already seen Moco lift its weight today. They do permissions, they have an MVVM implementation, biometry, media, and so on. So they're definitely worth checking out. Just like on Android, image loading is something that you'd outsource to a library. There's a couple of different ones like Compose Image Loader, Camel, but also Coil, one of the libraries that are becoming or that are very popular on Android, actually received a grant from the Kotlin Foundation to bring their library to Kotlin Multiplatform and Compose Multiplatform as well. And those, of course, all have their own flavors with caching, asynchronous loading, and so on. On a lower level, of course, most apps also need to do something like networking and persistence. That's mainly independent from the UI layer, but I just want to throw up the typical recommendations here. At JetBrains, we built Ktor, which is our multi-platform networking library. And all the image loaders we've actually seen, they all use Ktor under the hood to do the actual network requests. But you can also just use it for regular HTTP, WebSockets, and so on. If you enjoy the retrofit way of specifying your API calls, there's KtorFit, which is a multi-platform implementation of this kind of annotation style implementation. These libraries also play really nicely with Kotlin X serialization, which is our replacement for JSON or any other JSON library you might be using. And when you do actually have something that is worth storing, then you could either put that in Data Store as one of the official libraries from Android that's now multi-platform, but you could also use something like SQLDelight, which provides a very neat interface for relational data. By default, everything that you build comes with the same design artifacts and composables that you have on Android. That's what made this magic possible that we saw a little bit ago. If you do want to have design elements that kind of give you this more Cupertino style rather than just Material and Material 3, there's the community-led Compose Look and Feel project. And that one provides you with adaptive widgets that can actually change the way they look based on the platform that you're running on. It's still early days for this project, but it's already showing a lot of promise, I think. For anything else, there's the awesome Kotlin Multiplatform GitHub repository that shows that shows a general overview and gives you a bunch of different categories that you can look into. This is all an alpha technology that we only released a few months ago. So I'm really happy that we already have all the basic building blocks in place to build something that some people are comfortable putting into production. We're not, but they are. So yeah, but it's also, I just want to make the appeal that if you are working on a library, consider making it multi-platform, and if you're working on some kind of set of composables, whether that's fancy buttons or color pickers or whatever, pre-designed elements, publish them as Compose Multiplatform artifacts. And this is not actually a particular risk for you, because Compose Multiplatform artifacts are actually backwards compatible. So if you have a developer that's doing pure Jetpack Compose development, they can use all the Compose Multiplatform artifacts. They won't feel a difference in the actual experience of developing for Android. It just means that you cover a wider base of users for your library. And this kind of backwards compatibility is actually enabled by our collaboration with Google behind the scenes, where we make sure that these things stay in sync and don't diverge. My last point before I let you all go is something that I call graceful decomposition. Because this backwards compatibility is kind of an additional benefit. When Compose Multiplatform on Android is just Jetpack Compose, that means if you ever take away Compose Multiplatform from your project, what you end up with is just a regular Android app, right? So if for whatever reason down the line you decide you really want to build a native user interface for iOS, then all the work that you've put into building your UI, it doesn't go away. It's still a regular Jetpack Compose application that works and behaves exactly the way that you want it to. And because you're actually built on top of Kotlin Multiplatform, you don't have to throw away your business logic either. You can continue sharing that at whatever level you feel comfortable at, whether that's data and networking or business layer or the actual business logic, or even all the way up to your view models. You can do that. This is something that's honestly really unique for a cross-platform technology, if you ask me. And together with the fact that you already kind of have this code and knowledge sharing from all the stuff that you're doing as Android developers anyway, I think this is one of the real big superpowers with Compose Multiplatform. So I do hope that you go out and you experiment with this technology yourself, and if you do maintain a library, you consider supporting multi-platform. We're currently in the middle of alpha. Sometime in 2024, we're hoping to go beta, and then because time does move linearly, or so I'm told, Compose Multiplatform stable is sometime after beta. yeah. For your own exploration, we have a bunch of sample apps, and of course you can also talk to me if you want to see any of those in action, since I have them installed on my phone. The community has also been super busy building a bunch of different sample applications, from like small side projects to huge demos to fully working applications. You can find all of this by going to jb.gg/compose. We also have a channel for our community. If you want to have more Compose goodness, we have stuff on our YouTube channel where we kind of do a full walkthrough of building something from scratch. Mohit is also going to do a talk at this very conference tomorrow in this very room at 16:20. So if you want to see some more shared UIs with Compose, why don't you check that one out as well? Okay, yeah, Compose Multiplatform, or I would say Compose skills overall, are probably now more valuable than they've ever been before. All the time that you're investing in Jetpack Compose is now paying off double because you're building up a really transferable skill set. So yeah, I hope I'll be able to talk to a couple of you throughout the conference, and thank you so much for coming to this talk.